Hey everybody, we're here talking about deconstructing polynomials, and we're going to focus on using the remainder theorem and the factor theorem. So if we start with the idea of polynomial division, we take a polynomial just like a number, we divide it by something, a divisor, and we get a quotient, and possibly some remainder, right, left over. So what we know is that we can take the product of the divisor and the quotient and add the remainder back to it to get our original polynomial. Okay, and reverse that process of division, right? And that gives us this equation right here. So if we think about a polynomial in these terms, okay, and start from there, that's where we get the remainder theorem. So the first thing that we're going to do is we're going to assume that we're talking about a linear divisor, okay? Doesn't matter what our divisor is as long as it's linear, okay, whatever form it might be. And so it's doing a substitution, we're going to get this equation down here. Okay. Now the thing that you should notice is that the value of a is going to make this linear divisor 0, right? So if we were to plug in a here, not only would this be 0, but this entire product here would be 0, and all that would be left over would be our remainder, right? So if we think about substituting for a here, we could substitute for a in all of these, okay, which would ultimately give us this right here, okay? So we've plugged a into this expression, right? And we know that this part is going to be 0, so this whole product is 0, right? And all that's left over is our remainder. And so it leaves us with this result, that if we do division by a linear divisor, and our remainder is going to be equal to the value of the polynomial there. Okay, so let's take a look at this in action. So let's say we wanted to find f of 3. Well, normally we just go ahead and plug this value in. Okay, we've got 3 cubed plus 9 times 3 squared minus 7 times 3 minus 63. Nothing crazy here, but it does take some calculation and some exponents. If the numbers were larger, like if we're trying to find f of 8, we're going to have to take 8 cubed. Okay, since it is here, we're going to do that synthetic division, since we're going to need to do a linear divisor. So we're going to take advantage of the speed here. So we've got 1, 9, -7, and -63. Okay, and we're going to use the value of 3 right here. So we bring the 1 down, we multiply, we get 3. We add and get 12. We multiply and get 36. When we add, we get 29. Okay, multiplying, let's see, we get 60 plus 27, that's 87. Okay, and then when we add here, we get 24. So what this tells us is that f of 3 is equal to 24, right? And I bet we're going to find that out here. We've got 27 plus, let's see, that's 9 times 9, or 81. Okay, and then we've got -21 minus 63. All right, so let's see here. If we take 27 minus 21, we get 6. And 81 minus 63, let's see here, we're going to get 18, and when we add those together, we get 24. I know that was kind of weird there, but so 24, but it was much easier just to multiply and add, instead of having to worry about several terms. Okay, and you can see this would be very useful, especially if you're dealing with higher degree polynomials. So now let's take a look at another one. We want to find f of -5. Okay, so instead of plugging it in, let's just go straight to synthetic division, right? So 1, 2, -17, and -10. Okay, make our L and use -5. So the 1 comes down, we multiply, and we've got -5. Adding, we have -3. Multiplying, we get +15. And then when we add vertically here, we get -2. Multiplying, we get +10. And when we add, we get 0. So our remainder is 0. So it tells us the value of the function there is 0. It tells us that -5 is a 0. And if -5 is a 0, it tells us that x plus 5 should be a factor, right? And we should be able to multiply x by 5 times something to get x cubed plus 2x squared minus 17x minus 10, right? What that something is what's left over here, right? x squared at negative 3x minus 2. And you can multiply those together to figure that out, right? So this leads us to another important result, okay? If our remainder is 0, then whatever linear factor that we're dividing, or linear divisor we're dividing by is a factor, okay? We could see that here, right? I mean, if, and this goes in general, if the remainder is 0, okay, then it tells us that the polynomial is a product of that divisor that we're dividing by and some other smaller degree polynomial, right? It goes in evenly, okay, and we don't have to really even mess with that. We know that it's a factor, okay? So try that out. Again, that's going to be useful. This is going to be useful especially when you get to factoring polynomials completely in the last section.